All right, so here we are back at 10.2, and in 10.2 we are going to do solving systems, but without graphing. In fact, we're going to be using what's called the substitution method. All right, so for the substitution method, there's kind of like a three-step process. Number one, on one of your equations, you want to isolate a variable. Now, sometimes this is already done for us, like it is in this case. Y is already by itself. So there's no point in isolating anything else. We already have Y by itself. That's what we mean by isolate the Y, any variable. It could be X or Y, doesn't make a difference. But often there's going to be kind of an obvious choice on which one you want to isolate. And again, like I said, sometimes we're done for us. Now, the reason why we want to isolate is step 2. We are going to substitute into the other equation, because there's always two equations. So we're going to substitute into the other equation, which means here we have 5x minus 11, and that is equal to y, which means no matter what, y equals 5x minus 11. So we're going to plug that in for y down here. So the 4x stays the same. Okay, positive 2 is there, but instead of y, we're going to have a parentheses 5x minus 11, because again, y equals 5x minus 11, so we can substitute it into the other equation. And we have equals 20. So the only thing we changed in this second equation is instead of y, we have 5x minus 11. And now, part 3, solve. All right. So then we're going to, again, this is just like solving a regular equation. Use your order of operations. We got to get rid of parentheses first, so distribute the 2 through. We have 4x. 2 times 5x is positive 10x. 2 times negative 11 is negative 22, equals 20. Combine like terms, 14x minus 22 equals 20. Get x by itself by getting rid of the 22 first, because it's minus. We do the opposite. We add 22 to both sides to cancel that out. Leaves you with 14x equals 42. And lastly, we divide 14. X is equal to 3. So we have one solution, and x equals 3. So again, this is x, this is y, don't mix those up. All right. Now, once we have the value of x, we can, part 4 here, solve for the remaining variable. Okay. Again, sometimes I can solve for y first, sometimes I can solve for x first. Just depends on which variable you isolate to begin with. Now, the real nice part is we can take that original equation, this equation right here, y equals 5x minus 11, and since x is 3, we can plug in 3 in for x. So we get y equals 5x minus 11, and since x is 3, y is equal to 5 times 3 minus 11. Y is equal to 15 minus 11. Y is equal to 4. So that is the substitution method, and that's really the 4 steps. Step 1, isolate a variable. Step 2, substitute for it into the other equation. Step 3, solve for the one variable that's remaining. So here, once I substitute in, I just had x, so I can solve for x. And then once I have that, I can solve for the remaining variable. So those are the 4 steps. We're going to do a couple more of these. But that's really what they're all going to be like here. Okay. So next. All right. So here, before I already had a variable isolated. But here I don't, but I do have y by itself over here, except it has a 7. So the only thing I need to do is divide everything in this row, in this equation, by 7. So we get y equals x minus 8. Right? So what we're going to do, now that I have the variable isolated, y equals x minus 8, I'm going to plug that in for y here into the first equation. So that gives us negative 2x plus 2 times x minus 8 equals negative 16. And step 3 is solve for the variable now, which means, again, distribute. Negative 2x plus 2x minus 16 equals negative 16. All right. And I don't know if you noticed this, but we have, when you combine like terms here, what happens to the negative 2x and the positive 2x? All right, they cancel out, it gives you 0x. So we're left with negative 16 is equal to negative 16. Now, any time that the variable cancels out, like it did here, variable cancel out, you have two options: no solution or infinite solutions. All right. Now, no solution is if you are left with a false statement. I would say false equation. That might be easier. False equation. All right. Infinite solutions if you are left with a true equation. So the question is, does negative 16 equal negative 16? Well, yes, that's true. Negative 16 equals negative 16. So this is true, which means I have infinite number of solutions. All right. Now, if you remember on the graphing section, because I'm assuming you did the graphing section first, infinite solutions means they're the same equation. All right. And if you solve for y in both these, you would get the same equation. These are actually the same equation. You notice that if you divide by 2, you get negative x plus y equals negative 16. Divide by 7, we get x equals x minus, negative x plus 2 plus y equals negative 8. We would end up with the same equation, y equals x minus 8 on each time. So this is infinite number of solutions. If I got something like negative 16 is equal to 4, okay, or negative 5 is equal to 12, something that's not true, that's false, okay, then you would have no solution. All right. Now, it's only no solution if the variable goes away. If you're left with x is equal to 0, that's fine. That just means x is 0. It's still a true equation. It's still only one solution, just x is equal to 0. That's fine. X would be 0. X and y could both be 0. All right, it's rare for that to happen, but it can. Okay. So you only use no solution or infinite number of solutions if your variable goes away entirely. There's no more x. You're just left with one number equal to another. If it's true, infinite solutions. If it's false, no solution. All right. Next. Okay, now here, let's go ahead, since we kind of have something similar. It really doesn't matter. I'm going to do this bottom one because everything's 2, so I can divide everything by 2. Gives you y equals 2x minus, y equals x minus 1. So that's going to go in for y here. So we get 2 times x minus 1 equals 2x plus 8. Solve for the variable. 2x minus 2 is equal to 2x plus 8. Again, the step so far, I divided this one by 2. I could have done the top one. It makes no difference. I just did the bottom one because everything's 2, and you divide everything by 2, you get 1, 1, and 1. Once I had y isolated, I substitute this in for y. So that y becomes x minus 1 Distribute the 2 through 2 times x, 2x, 2 times -1, -2. Now I want to get my variables on one side, so if I subtract 2x over, what's going to happen to the 2x's on both sides? They cancel out. So you're left with -2 is equal to 8. Now this is back to where if the variable cancels out, no more variable here, am I left with a true statement or a false statement? A true equation or a false equation? Well, that's a false equation. This is false. -2 is not equal to 8, so there is no solution. And I'm done. All right, now this is the same thing we did. Again, we have x already solved for. We can plug it in, do the substitution method. So that one's pretty straightforward. And the last question you're going to get, no, it's just another equation. Okay. Yeah, so you're fine. Let me see, was there anything else? No, I think that's it. So those are the 3 times equations you're going to get. Either one solution where everything works out fine, no solution where you have, a false statement left, and infinite solutions where you have a true statement left. So let's do one more of these just to make sure we're all comfortable. So again, I could easily get y by itself here. I can also easily get y by itself here. So they're both pretty easy to get y by itself, but I'm going to do the bottom one because y is already over here. I don't have to subtract anything. So I'm just going to divide everything by 3. And that gives you y is equal to -3x minus 10. So that is going to go in for y right here. Now, if there's no number with it, I don't need to put it in parentheses. I mean, you can, but you don't have to. All right, so you can put it in as 2x plus parentheses -3x minus 10 equals -9, but there's nothing in front. So you're going to drop the parentheses anyway. So there's no point in really having the parentheses. You don't need them. But combining 2x and -3x gives you -1x minus 10 equals -9. Add 10 over plus 10, -1x equals 1. Divide by -1, because you can't have a negative. X equals 1 over -1, which is -1. So x is -1. Right. And then once we have x, we can plug that in right here. Y equals -3 times -1 minus 10. Y equals 3 minus 10, so y equals -7. And there we go. So that's solving using substitution. Okay. So go ahead and do 10.2, and then we're going to move on to do 10.3, which is solving systems again, but doing it in another way. All right. So you'll see a reason for that. Solving by substitution, usually I only do if I already have a variable by itself, and it's easy to get by itself. We're going to solve by using what's called the addition or elimination method next, and you're going to see a reason why it's a little bit easier to do it that way. All right. So go ahead and get 10.2 homework done, and then start on 10.3 when you're finished.